I'll go ahead and get us started. Thanks everybody for joining us for today's colloquium. Today we are going to be hearing from Malihe Alikhani, whose name I hope I pronounced correctly, and I'm sorry for not asking you that first.
That was great. Thank you.
Great, thank you. So her talk's entitled Towards Inclusive and Equitable Language Technologies. A little bit about Dr. Alikhani. She's an assistant professor of AI and social justice at the Corey School of Computer Science at Northeastern University. She's also affiliated with the Northeastern Ethics Institute, as well as the Institute for Experiential AI. Her research interests center on using representations of communicative structure, machine learning, and cognitive science to design equitable, inclusive NLP systems for critical applications such as education, health, and social justice. She has received multiple Best Papers awards at a whole bunch of very impressive conferences like ACL. I'm not going to read the whole list of acronyms. And we're very happy to have you here today. Thank you so much for joining us.
Thank you so much for having me for the introduction. Let me start sharing my slides. Can you all see my slides?
Yeah, looks great.
Okay, awesome. Yeah, so thanks again for having me. I'm very excited to share a couple of projects that we've recently worked on in my lab with you, and some results in the space of inclusive and equitable language technologies, particularly with generative models. I would love for this talk to be as interactive as possible. So at any point, if you have questions, feel free to stop me. We'll chat about things and then we'll get back. I don't have to finish all these slides. Right. So conversational systems are gateways to knowledge and community. They influence our social interactions online and offline, and as influential and important as they are, they may not necessarily be designed with minority communities in mind, or they may not reflect our societal values. These systems influence the information ecosystem, right? Online AI chat, AI moderation systems are sort of deciding what posts we see on our social media accounts. We talk to different kinds of chatbots when we want to renew our insurances, or get information about our bank accounts, just to name a couple of examples. And AI is heavily influencing the space of law and policy. One of the sort of directions that I care deeply about is how can we make sure that these conversational devices, models, systems that are now powered with generative AI are creating more inclusive spaces as opposed to leaving communities behind. Especially in the direction of social justice, we should think about fair treatment and equitable status for all individuals. Thinking about, do people have fair access to education? Do they have fair access to healthcare? And that, even sort of without AI, there are already problems. But what if with AI and with the way that we're designing it only for particular communities in mind, we just add to, enlarge this gap. So how can we think about the information ecosystem and think about fair information access, inclusive information access? And how can we use conversational AI to think about tackling sort of major challenges that we are dealing with, such as mental health and global warming pandemics. One of the examples that you will hear me talking about in the second half of talk today is about designing AI for deaf and hard of hearing communities. And the pictures you're seeing and the diagram shows the sort of, the unemployment gaps and rates in the US for these communities, and the challenges. Partly you can see how wearing masks sort of slowed down the the communication, and especially in the space of education. Overnight we switched to Zoom when pandemic hit, but Zoom was not a platform designed or a platform that can work for these communities. So how can we make sure in systems that we design, we think about inclusivity, we think about designing technology that can help minority communities? Just as an example, you will see this in my talk. When I talk about inclusivity, I often sort of think about intersectionality. Inclusivity begins from the understanding of the different vectors of social diversity. We think about accessibility. How can we make sure the structures, the systems we design are enabling different members and are engaging with people with different capabilities and preferences, as opposed to sort of, shutting their voices down. And of course, equity. So in my research, I often combine formal models of machine learning that allows us to study robustness and data bias and shift, that allows us to study success in multi-objective environments when we don't want to sacrifice accuracy for diversity, when we have in multiple dimensions, we would like to achieve better accuracies or better performances. I often borrow knowledge findings from cognitive science and social sciences and contribute to that body of literature for studying social meaning, for studying norm shifting, oppressive speech, power dynamics, language use in context, and linguistic injustice. And in all of the projects that we work on in my lab, we start by reaching out to communities, and we end the project by getting feedback from them, and if it's working, sort of making sure that it's deployable and they have access to it. So these are the three key components of the projects that we work on in my lab. Some of the ongoing projects, we are now designing AI systems to help kids, especially from that sort of minority communities, find access to quality STEM education. We work with teachers and students in the space of social media, and this is the first project I'll be talking about today. We have worked on social media moderation, mediation, and through that lens, we are looking into different biases, different sort of shift norms and behaviors that are inclusive or not. And we have a number of multimodal conversational AI systems in the space of mental health and cancer patient care. So I'm going to hopefully talk about two projects today for you. The first one is social media moderation and mediation. Let me see if I can, okay. Right. So this project was funded by DARPA for about 2 years. And the main question was, well, moderation, social media space needs to be moderated for obvious reasons. It is costly because hateful content on social media can impact, users' well-beings. At the same time, the moderators who were hired by these sort of large social media companies reported suffering from depression, anxiety, and other problems after short period of time working as a moderator of the space because of the sort of, the amount of hateful content that they were looking at. And the sort of the nature of the job. And a small sort of case studies that we did showed that a content that may get flagged as offensive, in Texas, it may not get flagged as offensive in California or New York, or there are differences in ways that people moderate with the same sort of guideline. So that is another sort of reason for us to think about ways that AI can help empower, not exactly to replace the moderators, but to empower them through platforms to sort of better deal with the content. The questions, the sort of the broad research questions that we asked were, how should social influence systems model user behavior and plan optimal responses systematically? What structurally differentiates and unites various social influence tasks? So one of the problems we decided, sort of one of the solutions that we put on a table when we started the project of social media moderation was, well, the social science literature suggests that you don't, also like our preliminary analysis showed that when you just when you flag a post and you delete it, the user is going to come back often, add another post that's even more offensive, and then they'll leave the platform. So a lot of the times the sort of flagging strategy for moderation not only doesn't actually really help, but also it may contribute to sort of further polarizing than the space. And there is literature, there are suggestions, and there are different ways you can nudge the users to show behaviors that are aligned with the rules and regulations of one Reddit forum, for example. One is oftentimes in face-to-face communication, people provide paraphrases of each other's, speeches and turns, so they can understand each other better, and to sort of offer avenues for discussion. Oftentimes in conversations, human-human conversations, we offer counter narratives. If someone says COVID vaccines are harmful in this way, we may say, well, that is not a fact. My understanding is that the research shows blah, blah. And then that's a kind of counter narrative. And that helps people achieve a common ground. And another sort of very successful strategy in communication is that we ask follow-up questions. We clarify, we elaborate. And so we thought maybe instead of just flagging content, we can train AI to offer paraphrases if possible, or to generate counter narratives that are grounded in facts. We needed a large data set for this. We didn't have a data set for sort of AI moderation. So what we did was, for a while, we monitored Reddit, sort of very closely monitored the thread and the posts that were flagged and the posts that were not flagged, and the sort of the details of the times and who's online, who's not, whatever the platform allowed us to collect. And we collected a data set of a little over, I think now it's a little over 2 million comments. And if we saw that a comment was flagged and removed, we sort of put that in a class of flag and remove, because if you miss that sort of window, some comments are flagged and removed immediately. So if you're not like closely monitoring the content, you won't be able to create a data set like this. The data set is in 6 languages. I think we've added more languages, and on different topics, on finance, sports, politics, news. And as you can see on the right-hand side, each Reddit forum, each Reddit discussion might have different set of rules. So it's not a sort of, just 5 rules for all the Reddit forums. Different channels, different discussions, they have different rules. And they are, even moderators are even allowed to, or the creator of the forums are allowed to modify these rules depending on how the conversation goes. So this is in itself a very interesting problem when it comes to machine learning, thinking about how you can design your moderation system so they respect the changing rules, or just thinking about, how sort of differences across languages. We have observations like a post with very similar content that was flagged in the US was not flagged in parts of Asia. And so, if I remember correctly, that was particularly about the role of women in society, for example. So there's lots of sort of interesting things to look for, different interesting questions that you can study in this data set. But I'm going to jump into the paraphrase. We wanted to use generative AI to paraphrase the content that was flagged as offensive or as sort of that was not aligned with the rules of the forum. So we needed to start with a data set that has the hateful comment on one side, and it has the counterpart, the paraphrase sort of match. It was not easy getting an IRB approval for this because again, it's like, looking at content that's violated. So they, the annotators who were linguists could only look an hour or 2 hours for every week. And we had to use AI to filter through sort of the content. So if you're interested in how you can write an IRB for this, I can offer some help. But we put together a smaller data set of 2K comments with their paraphrases. And we chose topics around sort of gender rights and politics and personal views. Like perhaps you've heard of Change My View forum if you've been on Reddit. And then we looked and see, well, what do we need? What does the model need to understand so it can generate the right paraphrases? And one of the key observations that we had was that it's very important for the model to look at the context, the thread, right? Because if it's just looking at that offensive comment, the chances that it can paraphrase it in meaningful ways while sort of retaining the meaning and the sense and all of that were low. So we thought in order to sort of bring this capability into these generative AI powered paraphrases, we can go to discourse theories and discourse structure. And I want to sort of for a second stop screen share and ask you to raise your hand if you know what discourse is or discourse theory. All right, we'll go over it. So, oh, Stephen. Awesome. So David Hume, and if you're interested in sort of the philosophical roots of this, you can check out the Stanford Wikipedia for I think a Stanford philosophy Wikipedia. David Hume argued that thoughts and ideas are connected by 3 relations of contiguity, causation, and oh, cool. Yeah, so our ideas are related, our thoughts are related using just a few inferential links. Later, linguists borrowed this theory and added to it and situated it in the context of documents and conversations, and argued that really, if you want to model the relationship between different dialogue turns, right? For example, John had a good night. He went dancing and then he got a very nice dinner. So you see that like the dance and dinner, these are all sort of, attaching to the main sentence that says John had a great night, and they're, adding to it and elaborating. So they said, that through just a few relations, such as contradiction, elaboration, temporal, logical, you can model all of these attachments and get a better sense of your whole sort of the context of the discourse. So what we said, we thought we can use such theories and data sets that are out there, so we can get labels for ways that comments and Reddits are related to the previous context, so we can get better paraphrases. Now, we had one problem for that, and the problem was the data sets that are annotated for discourse relation prediction are often only in the space of news, and there are news articles. We have a very small Reddit data set of like maybe 100, 200 pairs. I don't know off the top of my head. And so we needed a machine learning technique that can allow us, from this sort of large bank of news articles annotated with these relations, to sample a training subset that will allow us to predict the relations in the Reddit corpus accurately. So I'm going to go back and share my screen. Right, so we were after predicting whether the relationship is contrast, whether it's causal, whether it's logical. And we came up with this machine learning technique that allows us to measure the distance. If the topic of the Reddit forum is about health and bio or medicine, it would allow us to pick the right training set by understanding and measuring the distance between the train and test. It would also at the same time allow us to choose the better models, better classifiers, better parsers that can sort of output the right inferential links, the right labels for us. And I can talk about this more in the QA if you're interested to learn better about the technique. But with a bound, and this bound is available in form of a very easy Python package. The Python package is very easy to use, and you can use it for different purposes to choose to select your model or select your data set for similar problems. And so our model, we observed, does a better job when it comes to, getting us these labels that we need in sort of estimating the parser errors and the performances. And so what we have now with these better parsers is that we can the acronyms here, I hope they're not as scaring you. They're just different labeling strategies, but essentially they will give you the labels of contrast and elaboration and temporal and so on. So we parse our corpus, and then similar to sort of any typical language modeling, we pass it through a tokenizer, we'll update tokenizer, we'll resize the embedding and encode and then decode. And what we observed was that models like ChatGPT, different versions of ChatGPT, they don't return good BLEU scores or BERTA scores, which means they don't give us the best paraphrases, because these models, when you prompt them with hateful comment, sometimes they say, I'm not allowed to paraphrase or say anything, or, I'm not allowed to process this and so on. But also 40% of the time, I think in our case, they started getting back as sort of in a more conversational mode, like, why are you thinking that, as opposed to actually giving us the paraphrases. The best model that retains the meaning, but also sort of the sense, and is very easy to run, very quick to run, and is also trained using Reddit data, was Dialog GPT. So the Dialog GPT, improved by the parser and the sort of the discourses strategy, returned better results, better automatic scores. You can see the red bar. But also when we asked annotators, human annotators, to look at 300 pairs, they reported that the discourse aware model is better in preserving content, meaning, and in overall performance. It's more coherent. So you may say, okay, you have this paraphraser, who's going to use it? And that's a valid question. So we started Reddit forums, and we sort of, started by saying this forum is moderated by an AI agent, and people joined. So that in itself, you can say, well, the people who accept to join, there's a bias there. 100% agree with you. But 66% of the users who accepted, but the users who joined, 66% of them accepted our model suggested paraphrases when their posts were flagged. Now, this was a small study, and I think there's lots of room for sort of asking different questions in this space, and starting on different topics and sort of trying to work with different biases. But overall, it seemed that they chose to work with one of the paraphrases, and the forums were more engaging. So users stayed for longer, and the length of the conversations, the length was longer. And so overall, it seemed more of, it seemed that the paraphrasing approach helped sort of maintaining a more inclusive, engaging conversation. We also, as I mentioned at the beginning of the talk, used this model to, and the other models for counter narrative and question generation, to build a platform for moderators that can work with. And then I said, well, if we have this model that can, generate paraphrases, I want an add-on on my Chrome, Google Chrome, that when I don't want to look at hateful messages on different forums, I can just turn it on and it will show me the paraphrase. So that add-on is also available if you're interested in using it. I can share it with you. So takeaways, combining discourse frameworks with language models can help us better model inferences and generate text that better retains the meanings and purpose. We saw that giving people alternative options will definitely help in creating more positive and engaging environment. In this study, we didn't get to work with images at all. And as you can see on the screen, part of the content might be in the image in these, and social media posts are often multimodal. So that's a problem we've recently started work on. It's a really interesting problem when it comes to sort of the studying and modeling the dynamics of text and images, the emotion that the images convey, how they work hand in hand, what part of the content is in the image, what is in text, and so on. And then I just want to sort of tell you very briefly about the recent paper we presented at AACL on counter speech or counter narrative generation that's also inspired by sort of these theories of discourse. So if you're interested, you can check out the data set and the model with like more recent language models that can generate counter narratives. And I guess I will end this section with this note that you may say that in different places, different locations, we may need different, systems given the tastes and the preferences and the beliefs of that state, of that, of that context. And one way that we've seen improvement in ways that we can better incorporate people's votes, users' votes, and sort of democratize these models is by bringing in lessons from active learning into the training process, and sort of distilling knowledge from language models, and think about using these for moderation, for flagging, for generating paraphrases. So in a sense, active learning, different versions of active learning algorithms have helped us build more inclusive, less biased AI moderators. And it's just, again, another sort of signposting. If you're interested, I'd be happy to share this papers with you. Most of the papers are available here. I'll share the slides with you as well. So if you want to take a look, you can do that. The next section of the talk, and I'll check the time now, is mostly about accessibility. So I'm going to stop here, and I hope you have some questions for me about this section we can discuss.
Yeah, I really liked how you integrate. Like, it looks like we would find a nice way to actually nudge user to actually accept the model, suggest like accept nudge from model. But my question is more of technical side. So you mentioned you have this cost parser, have that integrated into GPT. Like, how did you like how is it being integrated? You kind of flatten the tree and put it as an input, or like you do something else?
So there are different ways we've tried, and the best one was the simplest one. We tried different fine-tuning mechanisms, we tried different prompting mechanisms, but at the end of the day, if you just use the parsers, right, to and work with the parsed content as the input. So instead of inputting sentence A dot sentence B, you input sentence A, contrast sentence B, and then you ask for the paraphrase. Or if it's more complicated, you have more relations, you just add the tags, right? And the ways that you're sort of preparing the input. And that turned out, that gave us the best results. One other way we tried was to use LLMs to parse on their own and come up with their tags first. So how they say like the chain of thought systems and mechanisms that recently are people using. That also helps, but it's not comparable with just actually parsing and working with that content. Does that answer your question?
Yeah, very clearly. And like, do you have any notion of like usually how deep, like, do you just parse relationship between two pairs of like a pair of sentences? So like, do you throw in a passage and it kind of parses the tree structures for you?
Yeah, so it's interesting. Well, as you know, I mean, you may know this, PDTB is a very shallow discourse structure, meaning it's mostly it's studying the relationship between the senses, right? So you have just one label between two different sentences, so very shallow. And you can include like the previous sentence as well, so you're working with two, but it's not very hierarchical. With RST, I think and this we report in the paper, but I think we worked with we didn't work with very, very deep trees, but when you get to the bottom of the tree, the accuracy drops, the accuracy of the parser. So maybe just the previous 3 to 5 sentences and their RST parse. So the representation is easy, the judgment is easy, because if you want to make this really complicated and if the forum is really long, then the chances that you can actually model these inferences with machines are just lower. You don't actually need the deep parse trees anyways, is our findings, and we discussed that in the paper.
Oh, I see. Thank you.
Yeah. Sarah, do you want to ask your question, or do you want me to go ahead and read it? So the Reddit users, the question is, the Reddit users, were they in the lab, or we just posted online. We created these forums, and we advertised on Twitter, we advertised everywhere. Everywhere that we could. And then so we didn't actually get to contact the users at all. Yeah. There's another question. Hi, Stephen.
Hi, yeah, I have another question. So I was just curious,
Yeah.
what was the topic of these? I guess you created subreddits. Like, what was the stated topic? Was it AI moderation or something else?
No, wow, I love that idea. No, I wish we could have. We So we started, I believe, 20 subreddits in different spaces of politics and health related, and we tried to go with controversial topics at the time, which one of them I'm sure was pro-life, pro-choice at the moment, at that time. But and then only, I think, and this must be in the paper, I think only 6 of those subreddits were active. The rest of them, maybe a couple people posted and no one really picked up on them, so we didn't get to study those topics.
And so for the ones that were active, were they actually talking about what they were supposed to be talking about, or did you find it like, oh, they got it moderated and then everyone started talking about the moderator?
No. They were like the content, because I compared it with similar subreddits. It was very similar to, they were having real conversations. So AI moderation was not part
So they knew they were
of their
being moderated,
discussion.
but they weren't like diverging topic wise because of that. Cool.
No, but one observation I've heard a lot is when they work with AI, like one of my colleagues were just telling me last week, and she's working in VR AI moderation, and she was telling me that the moment you tell them it's moderated by AI, they start showing like weird
Yeah.
behaviors. They jump out of the window and they do crazy things to push the limits of AI. I guess because maybe that is closer to like video game scenarios, as opposed to like people want to have conversations and they're seeing, yeah, it's moderated by AI.
Cool. Thank you.
Cool. All right. Awesome questions. Thank you. So let me share my screen again, move to the second part of the talk. I'll try to go quick so there's more time for QA at the end. Okay, so I've already told you sort of the story with meeting with the deaf and hard of hearing communities around DC a little bit. And in 2020, I met with them in the middle of the pandemic, and that really sort of inspired me to take action. And I started a series of summer workshops for deaf high school students, and started looking into how we can help them, empower them, especially with for education using NLP. And so we ended up writing this position paper as the first paper that came out of the project, that was an invitation to the NLP community to work on sign languages. I'm not going to stop a screen share and ask you, but if you know the answer, put it in the chat for me. I'll wait for a second. How many sign languages we have around the world? What do you think? There's at least 4 on the screen. More than one. Any ideas? 20, 50?
I'll go with 20 as a guess.
20, okay. Anyone else? 200. Yeah, that's right. At least, over 200, over 200 all around the world. And we have over 70 million individuals that are deaf and hard of hearing around the world. And the number must be more than that. This number is old. Just in the US, as of 2021, I believe, a little over 4 million people reported that their first preferred language for communication is sign language. And so when we say that, it means that they don't prefer to read, English as opposed to sign and talk. That's their first language. So when you type, or when you sort of, push them to do something else, that means you're forcing them to talk in a different language, as if they're talking a different language, they're communicating in a different language. It's not a surprise for you that most of the language technologies that we have are only designed for spoken languages. So this is translation systems, interactive agents. Most of them work with speech and so on. And so we're excluding people who have different preferences for communication. In that position paper, or that invitation that also won one of the best paper awards that year at ACL, we argued that from the year 2000 to 2020, we haven't really done much as a community for modeling sign languages or designing systems that can work and for these communities. Whereas if you look at all across computer science, you'll get sort of better numbers. And you may say that is because sign languages are inherently visual, so computer vision should study them. I will argue no. It's not enough for us to detect boundaries. It's not enough for us to think about just detecting finger spellings. We need to think about representation. We need to think about building all the building blocks that helped us get to GPT and Siri and Alexa and all these different successful NLP models that can help us and support us in different tasks that are equipped with reference resolutions and different ways of sort of representing this language, which we are not working on. And by the way, part of this is part of the sort of the curve that you see, the line that you see is going up, is because it's not because we are designing technology for signers. It's because the data sets are easy to work on, the finger spelling data sets for certain benchmarks in computer vision for detecting boundaries. It's not that they're thinking about what is it that they need, the community needs for when they walk into hospitals or education, or what is that actually very interesting scientific problem that is at the intersection of NLP and perception, and and we're solving that about meaning, right? It's not about that. And so the paper encouraged people in our community to think about different problems, and we surveyed a long list of problems that we can try to solve as a community. And one of those very important problems is thinking about data collection. Bringing people in the lab, collecting data, annotating it is really costly and time consuming. Often people report that for 1 minute of signed data, they had to spend 600 minutes planning, annotating, sort of putting it out there and all that. So if we can design AI tools that can allow us sort of better connect with communities and better process the data and better find the boundaries and better come up with ways that we can model the interactive aspect of it, it's going to be a huge help for making progress in this space. Another thing that I would like to share in this space is the community necessarily does not have a positive experience working with computer scientists. So it took me a few months to convince them that I'm not going to go there and ask them to wear heavy gloves that are sort of hooked with wires and batteries, and then I'm going to disappear after I collected the data. So thinking about sort of really respecting their times and the limited resources that they have, and really redesigning the ways that we are thinking about doing research. So we're studying problems that can help them. I'm gonna very quickly, I don't have a lot of time, but I'm gonna tell you about two things. And if you have my, I don't know if you can see my face or if you're just looking at the slides, but this one I can perhaps explain better. This is a sign for rain in sign language. This is heavy rain. Prosody matters, intensification matters a lot. And when you miss these subtleties, you're missing a lot in the representation. Another point is making sure we include faces and facial expressions in modeling sign languages. Our study showed last year that up to 40% of information, especially for Black ASL, was represented in facial expressions. And so if you are only looking at hands and manual signs, you're missing a lot. You're missing whether it's a WH question or yes, no question, or whether it's negative or positive, or even, crazy versus lawyer, or expensive versus very expensive. So what we did was we worked with linguists and cognitive scientists, and we tried to use also AI to augment the annotation so we can better model prosody, so we can better model facial expressions. We also use different techniques for sort of extracting more features from facial muscles and model emotion in faces and see how we can put those together with the manual signs. There are a few innovations in the space of sort of how we encode things, and working with dual encoders, working with glosses that are intermediate representations helped us a lot. Adding more features, including more features at the training time related to face and facial expressions helped us a lot in better modeling the output, the meaning, but also generating better skeletons. Another important problem in this space is evaluation. When you understand sign or generate sign, typically the automated technique that we look at is very similar to text, where we do back translation and we compare text with text as if, we're looking at n-grams or something like Berta score, and we compare that, and that doesn't really evaluate all the subtleties that I just talked about. So this is a huge, fascinating problem to think about. That is not just for sign, but also gesture and other, richer multimodal features that we would want to study in communication. The strategy of using linguistics and the grammar of sign, and I should say, it didn't take us a lot of time to find ways to include more grammatical features in the annotated data in the intermediate representations that were glosses. Helped us get better results. Human users rated our model better. It better preserved the prosody, and it better showed sort of improvements of modeling facial expressions. The model also, if you compare with ground truth versus the baseline, you see that learns to better use the signing space in front of the face and the chest, which is very important. We still have these very weird cases, which we don't know why the model get there exactly, but you see that suddenly a joint starts growing in generation when that's not in the training set. So there are lots of interesting ways that we can think about adding constraints, right, to the generated content or to the ways to the meaning space that we're modeling. We use all the things that I just described, not all of them, partially, and used also large language models. This is Llama and GPT. And in the Amazon Alexa TaskBot Challenge, we were one of the participants, and we were one of the winners this year. We use this to make sure that the bots that are equipped with the screen are accessible to deaf and hard of hearing. So we didn't get to actually fully end-to-end generate signs, but we got to retrieve signs and create something like this, where if they want to work with ASL, they click on it, and we are retrieving different parts of video and explaining, guiding them step by step to work with those instructions. I guess this was just one sort of application of that. And again, I wanted to say here, the message is still, even when you're working with really large models, and first of all, they're not doing well at all with any sign language task, but still learning ways to incorporate lessons from cognitive science, how we can design human-like systems that people can interact with, how we can design systems that are reliable and controllable and safe. We ought to go to cognitive science and social science and linguistics and find ways to incorporate this knowledge into the generative AI models that we're building, that we're fine-tuning, that we're training. And another important message from this section is engaging and consulting with users and community members is the key here. The exact amount of time we can spend to just work with a finger spelling data set and focus on a simple, like a simplified machine learning task can be spent on an educational application. So we can put out an avatar that can help them learn different key STEM signs, such as cell in biology, or they're really eager to learn about AI and data science. And this is not out of reach if we work with these powerful models that we have and think about augmenting data and working with them to help them find access to information when they need. I don't have time to cover this section, but in the same Alexa project that I mentioned, and building on the techniques from PAC Bayesian machine learning, we got to model the long tail of the distribution, and that allowed us to enable Alexa to understand African American accent much better. And so we could reach out to community members around Pennsylvania and New York. And they had good experience interacting with our devices for the first time, most of them, because they were really frustrated that the system couldn't understand them. But the techniques are the same. As I described, it's working with the long tail, it's working with very limited samples in the data, and making sure we weigh them properly so the model can perform. I am going to skip to show you the name of the people who actually made all of this possible. This is my wonderful team for the Alexa competition. My students, my collaborators from Gallaudet University, and for the social media part moderation, my colleagues at SRI Research who helped us with that research, and the funding agencies. And thank you so much for having me and for listening to me, and look forward to discussing your questions with you.
Thank you so much. I think we've got time for 2 or 3 questions. Go ahead, Sarah.
Sarah.
Hello.
Hi.
Thank you so much. This is such a cool area, and it's so interesting that you're going into ASL, and well, all of SL of their many hundreds. And this is not my area of expertise, so I apologize in advance. I wanted to ask about this, I guess, provocative statement that you made about that it's not the role of computer vision to do this work, but it is the role of natural language processing and linguistics. And that strikes, I mean, that seems intuitive, but also I wondered if you could talk a little bit more about that, and sort of like what the different positions are on that, because it seems to me that there are, just from a like computational standpoint, right, there you're going to need both, and drawing from both sides. So just be curious about that, the state of affairs with that.
Yeah. So, we need to model meaning if we want people to talk to our AI agents, our avatars, right? That can also sign. And the complexities of a language is not something that you can just model with the boundaries that you get from one of these models that will get the hand position, and it will give you the, oh, now Zoom is getting my hand. Okay, sorry. Let me lower my hand.
Exhibit.
Right. So I'll give you an example. In sign language, there's a lot of reference and co-reference, right? So they say Sarah, Kate, and they keep referring to it. Or this may be a school, this may be home, and when during in the evening, the places are swapped because then they are here. the main speaker is here. Just to give you an example of how complicated and fascinating it might be, the ways that they use the space in front of them. And so I'm not necessarily arguing it's not computer vision, but we need to model meaning. We need to model this structure. We need to model the communicative goals. And in all of this, NLP You cannot find these in computer vision papers. I wish we could. I hope we get there. Well, when we think about perception and different ways that it, is connected to. But oftentimes, especially when it comes to ASL, and you look at these papers, they're mostly going, best case scenario, going from like ASL to text with some sort of a translation in the weather domain. And if you talk to the community members, they're like, we look at our phone for weather. We don't need you to train like large data sets. And right, I mean, there are starting points, but since we wrote the paper in 2020, 2021, many people, many groups, at least I know in the US, have started working on it. Or now we have a track at ACL, and we're trying to add this track to different workshops such as a Star Sim and Connell, and so it's a very it's all positive. It's not, but I like to go around and invite people to work on it because it's very cool and not many people are working on it.
Thank you so much. That is awesome.
We've got one more question in the chat. Jose, would you like to ask that out loud? Oh, gotcha. I'll read it out loud. So Jose says, you brought up a good point that intended intensity and degree matters. And I think this is related to the sign language.
ASL, yeah.
How is this captured and accurately represented by the AI forum moderator?
Oh, so I guess the first part of your question is about ASL and the second part about moderation. They were like two different projects, just to clarify. But the way that the intensifiers are modeled is that we take into account now the speed as one feature, right? Which was not represented in the previously labeled and sort of studied model data sets. So that sort of either you can reassign the weights of your machine learning model if you're working with an end-to-end model. If you are actually going to cognitive science papers, there are lots of interesting papers from neuroscience to linguistics to psychology that describe why this is a universal behavior, that when we have a question, the hands go up or the head is moving some sort of, in different ways to emphasize that behavior. And so that we can find ways to represent that in our data to teach our model to follow this. So that's sort of how we went about modeling intensification.
We've got one good question from Dr. Bethard.
Okay.
Do you want to go and ask Steve? Yeah.
Sure, I'm going to make you speculate because where's the fun in asking you something you already know the answer to? But so there's lots of multilingual models for text, and my question is, you could imagine trying to do the same thing for sign language, as if it wasn't already hard enough to model sign language. Do you think there's greater or lesser potential for those to be useful, for multilingual models to be useful for sign language versus text?
Let me ask one clarification question. Are you suggesting we use this multilingual embeddings for modeling ASL or modeling the 200 sign languages?
I mean, I assume that you would model a 200 sign language, not that you would try to cross sign and text languages. Although I guess that's a whole other, possibility.
That's a whole other question. Yeah. And I think working with multilingual embeddings help because they learn some features of context and common sense that might be helpful. But your question, to answer your question, we have a project that it's taking us 2 years and we haven't been able to convince the reviewers or the other people this, but here is the problem. We reached out to a university in China and we could get a very small data set. The domains are not exactly matched with ASL. And then we have the German corpus, the DGS corpus, and we're trying to work with this multilingual embedding and think about easy translation, tasks for it. The performance is not good, mainly because it's really hard to align data when it's in sign. the glossing mechanism is completely different. So you know, we've been trying to, I guess like the ideal scenario would be, well, for weather or for a topic that's widely, you know, used, maybe chit chat, daily conversations, we can actually have people who sign in different languages, different parts of the world, sign the same content. So we have a very small core data set to start from. The way that we started by working with the existing sets, it's been really difficult. We have some promising results and directions, but they don't look as good, especially with the automated evaluation metrics, which is the reason why reviewers are complaining. But we've learned some very interesting things about the underlying behaviors and the linguistics of signs across, you know, different. There is this, and here is another important point. There, I was speaking to the head of the European Endangered Languages Archive a while ago, and they are willing to let us use the data, but it's really hard that they have from all over the world. The way that the data is collected, though, is not good enough is not machine readable, right? You know, it's very dark, the background or the light, or you can't see the hands. And even, you know, people like, I know a little bit sort of Persian sign language, I'm from Iran, and even I couldn't interpret what they are signing, you know, how they're signing and so on. So I guess like one project is, how can we think about, you know, all these linguists, they do amazing work, they go and document different languages and so on. How can we come up with a guideline that it's easy for them to follow so we can use that data? Because a lot of it is not usable, unfortunately, by computer scientists.
Thank you. That's a wonderful answer.
All right, we're at time. Thank you so much, Dr. Alikhani. That was so interesting. And we really appreciate you taking the time to join us.